This is the quick start guide for the 7th generation DF700 series moisture analyzer. I'm Matt Chambers, Head of Engineering here at the U.S. Technical Center.
And I'm Phil Rogers. I'm the Senior Applications Engineer here at the U.S. Technical Center.
In this video, we'll cover the unboxing of the unit, as well as the initial startup and setup of the analyzer.
So here's unboxing the new DF700 unit. You'll notice there are 4 latches, one at each corner of the crate. You can undo those latches and then with 2 people lift the top of the crate off. And inside will be your analyzer, as well as a power cord, your documentation packet, which includes the certificate of compliance. A USB with a digital copy of the manual will be located inside the analyzer, and your applicable connectors will be on the rear of the analyzer. Please note that this analyzer weighs approximately 80 pounds depending on your variant, so this is a 2-person lift.
We're looking here at the back of a DF760. Other variants of this model line will look slightly different depending on the configuration, but the DF760 has everything that you can possibly have on the back. It's a fully populated gas panel. And we start off looking at the aspirator. Aspirator requires 15 liters per minute at 80 psi. That will come in through the stainless steel tube down at the bottom there. You see that pointed out right here. 80 psi at 15 liters per minute. You have your bypass flow meter right there. We go over to the sample inlet right here. That is VCR fitting. There's also an O2 span inlet below the sample inlet, also a VCR fitting. This is the only variant that has 2 VCR fittings. And after this, we'll go up to the regulator and the pneumatic inlet. Again, the pneumatic inlet is only present in analyzers that have gas valves, as part of the option package. We go over to the connectors on the side there. We got relay connectors, 4 relays each for oxygen and moisture. We have 4 relays for oxygen and 4 relays for moisture. We have analog output for both oxygen and moisture, analog output at the bottom, and serial comms there in the middle. All these connectors will be fully populated in the analyzer when you open the box. We're looking here at the Gen 7 DF700 user interface right now. And you see the screen is quite a lot larger than it was, and more visible for that matter, than with the Gen 6. However, the information is pretty much the same with a couple of add-ons. Obviously, we have our moisture concentration displayed here boldly in the large numerals. You have your status up here, OK, that tells you get the green OK. That tells you that your analyzer is working OK and you don't have any problems going on. You have your date and time shown up here. You have your analyzer serial number shown here and model number shown here. We have a DF750. We have the cell pressure shown here. The gas is helium right now, so that runs at atmospheric pressure. You have your analog output shown right there, your analog output range. Right now it's set for 0 to 100 ppb. And then you have your chart recorder right here, which shows the displayed moisture values. This is an auto-scaling chart. Right now it's set up for 30 minutes, but that's user configurable as well. And then you have your reference spectrum shown, you can see right there. And if you get a good reference signal like you're seeing right there, that tells you that the analyzer is locked onto the moisture peak and everything is functioning as it should. So we go into the menu structure here. I just press the menu button right there, and you get this drop-down menu. Again, this is a 750. 760 is going to be slightly different. But you got all your user selectable, user configurable items that you have right there. So if you're setting up the analyzer, the very first thing you want to do is go down to Analyzer Setup. So you navigate using the arrow buttons here. So we just go down to Analyzer Setup, and you get these various selections that you have right here to configure the analyzer to the task you want to do it, use it for. So we start off, the very first thing is a sample GSF, and what that does is that lets you know, or lets the analyzer know what the background gas is going to be. So we'll show you what that looks like in there. These are the different background gases that you can configure your DF700 for. You can do, most people do 100%. You can see right here we're set up for 100% helium, but you can have it set up for mixtures as well. Some people have it for CDA, in which case you'd have 79% nitrogen and 21% oxygen. And it doesn't really matter. You can do mixtures of whatever you want, but it just has to add up to 100%. And then your pressure range that you're going to need to adjust your aspirator for will be displayed right there. Again, we're working with helium right now, so it's running at ambient pressure, 730 to 830 torr. All right, the next thing we're going to go into doing after we've set the GSF is to go in and set the alarms, show where the alarms are set. So again, you go down into Analyzer Setup, and you get Alarm Setup, the next one down from Sample GSF. So you get 4 moisture alarms, you get a temperature alarm and a pressure range alarm. They're all fairly intuitive as to how you want to set them up. But we'll go in, we'll look at the moisture alarm first, and we'll turn that on and show you how it works. Okay, so in your alarm setup screen, you got this little window right here displayed. You can see your alarm is currently off. It's set to trip below the set point. You can set it to trip above the set point as well. We have the set point is at 1 ppm, so it should trip the alarm when we activate this alarm. And we have a relay assigned right here. You can assign it to whatever relay you want, or even multiple relays assigned, or multiple alarms assigned to the same relay. So it's pretty flexible. There's no right or wrong way. It's whatever works for your particular system. So I'll go and turn the alarm on, and then hit enter to accept. And there we go. We have our alarm showing right there. We got alarm 1 is showing us below 1 ppm, and so that's how the alarm setup works for you. So I'm going to go back in and turn it off, just so we don't have to look at that screen. And we'll just turn that alarm off, hit return, and there you get your status OK again. Okay, the next thing that you want to go in and configure is your analog output ranges. So we'll go ahead and do that again. It's going to be in the Analyzer Setup selection. Next one down, analog output. So we'll go there. Now the analyzer is configured with it's a pretty flexible analog output feature here because of the wide dynamic range of the analyzer. You can go all the way up to 20 ppm moisture. If you have your analog output set up for 4 milliamps is 0 and 20 milliamps is 20 ppm, you're going to have no resolution whatsoever out of it. So what you want to do is you scale the alarm to match the range that you're expecting to be in. Right now, it's kind of the default settings here. 0 is 0. Full scale, your primary full scale is at 100 ppb or 0.1 ppm. And you have your expanded full scale A and your expanded full scale B. And what these do is if your output were to exceed 100 ppb, it would automatically switch to the expanded full scale A, and all of a sudden your analog output would be scaled for 20 milliamps at 1 ppm instead of 100 ppb. You can assign a relay to that so that if you're talking to a PLC, you want it to know what the analog output is, you can just assign a relay contact to both expanded range A and expanded range B, and that will keep your PLC recording accurately. So if you're going to be setting these, you navigate through here with the next button. So we'll go down and we'll change our primary full scale to something other than 100 ppb. We'll bring it down to let's bring it down to 50 ppb, or 10 for that matter. Why not? That makes no changes, but you see the analog output scale right here is now at 0 to 10 ppb. And if the reading exceeds 10 ppb, it will automatically change scale. As a matter of fact, I should probably just go in and I'll show you. I'll set it down to 5 ppb, and that way you can see the response of the analyzer. And so we got it down to 10 ppb. We'll bring that down to 5 ppb. So now you can see that the expanded full scale is shown as 0 to 1000 ppb, 1 ppm. And so that's what your analog output has scaled to, since you're greater than the primary full scale of 5 ppb. So it's completely user configurable. There's no right or wrong setting. The right one is the one that works for you. Troubleshooting the analyzer there are some tools available to help you determine what's going on if you think you're having problems with your analyzer. Go down into the diagnostics menu selection, and you have your signal monitor. The signal monitor has a lot of parameters in it that are critical for interpreting analyzer health. The most important one is P1. If P1 is at 1, the analyzer is in all probability working okay. That indicates P clock. That tells you that the reference signal that you see right here is properly locked onto. The analyzer knows where it is and is working properly to keep it in the proper location. P2 is your laser chamber pressure. The laser chamber is isolated from the rest of the Harriet cell and is pressurized, and that's to keep ambient air from intruding in ambient air, ambient moisture coming in and corrupting your readings, and as well as any residual moisture that may be in there after the purge. Because it's at such a high pressure, the peak will be very broad and wide and low and will be easily offset. So if P2 is your current laser chamber pressure, and P11 is what we call the original laser chamber pressure, which is where it was at the time the analyzer was shipped. P3 is your sample detector DC. We call it the SDC. And P12 is, again, your original SDC. Now, this is going to vary somewhat. The SDC is going to vary a little bit based on the moisture concentration, age of the laser. Just a variety of things can have an effect on the sample DC. The main thing that you want to concern yourself with is that is, you see the original is at 530. If your current one is down at 100 something, well, that is an indication that there may be a problem. You probably flag a system error at that point. P4 is your cell temperature. That, again, as opposed to the original cell temperature, that's important because the cell is heated to keep the optical alignment consistent and help with the desorption of moisture that's carried that way through the plumbing. Again, you got your cell temperature and the original cell temperature. These are always going to be pretty close, like you see right here. Right here, P5 is we have our laser temperature, and P6 is a laser temperature set point. P14 is the original laser temperature set point. Now, the laser temperature can drift somewhat over time. The analyzer automatically compensates for the take care of laser drift, laser aging. Various subtle changes take place with the output characteristics of the laser, and the analyzer automatically compensates for all of that. What you want to worry about with the laser temperature is that P5 and P6 need to be within 0.5 degrees of each other. And that's degrees Celsius right there. If they're further apart than 0.5 degrees Celsius, that's going to flag a system error because the peak centering will no longer function, and some corrective action will need to be taken to deal with that. P7, P8, and P9 don't have any diagnostic value, and those are fit RMS errors and things like that. You fully expect those to be quite variable over time. You can see that these have been taken out on the original values. Some number of years ago. We've kept this as a legacy signal monitor over the years because it is quite useful for giving a quick overview of analyzer health. At this point, we'll escape to close that window off. And what we do, if you do wind up getting a system error, or if you have any questions about your analyzer health or performance at all, there's a feature that allows you to download system data. And what you'll need is a flash drive. Oh, there it is. You get your flash drive, and the analyzer is equipped with a bunch of USB ports inside. As you see up here, there's an empty USB slot. Put your flash drive in there, and then go down to download system data. Right? It gives you the date. What the system data will do, it will download 10 days worth of data from the date selected. Now, if you wanted to, if you wanted to gather information on an event that happened last week or something like that, you can change this date, and it'll go 10 days back from whatever date you select, as long as the analyzer was around at that time. It'll record that data, and you can retrieve it. So we'll just press enter to download, and you get your typical taskbar being displayed there. And there we go. You've got your system data. You can reach in, get your flash drive, and then you can grab the attachment that is deposited on the flash drive by this download process and email it to your local service center. Once you've downloaded the files, bring it back to your PC, your laptop, your desktop, or whatever, and open up your USB disk D, and you get all the files. We got a bunch of files in here, but the one that you're interested in is sysdata. And you can see we got a couple on here, but the one you want is the one from today, which is 2/23. And what you are going to do is take this, copy this file here as an attachment, and put it into your email, and send it to your local service center, and they can open that up and look at the data and comment on the analyzer's performance. Well, this concludes the quick start guide for the DF700. Thank you so much for watching.
For more information on this product as well as our other product lines, there'll be a link in the description to the Servomex website as well as this product page. Thank you for watching. Until next time.